Dear students, Assalamu alaikum. Welcome to the Grade 8 e-learning session, week 5. I am your mathematics teacher. Today we will start the unit number 2, real numbers. Let's start our lesson number 1 with the definition of rational numbers. The numbers that can be expressed in the form of P by Q, where PQ are integers and Q is not equal to 0, are called rational numbers. For example, 1 by 2, 1 by 3, 1 by 4, 2 by 3, 2 by 7, 3 by 8, etc. All of these numbers are rational numbers. We observe that all the integers are also rational numbers. The set of rational numbers is denoted by capital Q. So, the set Q contains the elements -3, -2, -1, 0, 1, 2, 3, and so on. 1 by 2, 1 by 3, 2 by 3, -1 by 4, -1 by 3, -1 by 6, and so on. So we conclude that the set of rational numbers consists of negative integers, positive integers, 0, and all the numbers in fractions. The numbers which cannot be written in the form of P by Q, where PQ belongs to I and Q is not equal to 0, are called irrational numbers. So we observe that all the numbers in square roots are irrational numbers. For example, square root of 2, square root of 3, square root of 5, square root of 6, and so on. But the perfect square and the square roots are not irrational numbers, they are rational numbers. For example, if we take the square root of 4, we get 2. If we take the square root of 9, we get 3. And square root of 16 is equal to 4. And these are all the rational numbers. The set of irrational numbers is denoted by Q prime. So, the Q prime is equal to plus minus square root of 2, plus minus square root of 3, plus minus square root of 5, so on, pi, e, etc. So these are all the irrational numbers. Dear students, how can we differentiate the rational and irrational numbers if they are given in the decimal form? For this, we define the terminating and non-terminating decimals. If we convert the rational numbers into the decimal form, we observe that the number of digits after the decimal are limited or finite. Then we say that they are terminating decimals. For example, 1 by 2 is equal to 0.5. 3 by 4 is equal to 0.75. 5 by 2 is equal to 2.5. You see that these are all the rational numbers and they are terminating decimals. If we convert some of the rational and irrational numbers to the decimal form, we observe that the number of digits after the decimal are unlimited or infinite. Then they are called non-terminating decimals. For example, 1 by 3 is equal to 0.3333 and 3 is repeating infinite times. Similarly, square root of 2 is equal to 1.414213 and so on. Pi is equal to 2.7182818 and so on. So in all these numbers we see that after the decimal the digits are non-terminating. If we transform the rational number into the decimal form and we get the repeated pattern in the decimal form, then we say that it is a recurring decimal. For example, 2 by 3 is equal to 0.6666. So 6 is repeated. In 1 by 3 we have 0.333 and so on. In this case 3 is repeated. 37 by 11 is equal to 3.363636 and so on. So 36 is the repeated pattern. When we convert the irrational numbers into the decimal form, we get the non-repeated pattern in the decimal form. Then we say that it is the non-recurring decimal. It happens only in irrational numbers. For example, square root of 2 is equal to 1.41421356 and so on. Square root of 3 is equal to 1.7320508076 and so on. Similarly, pi is equal to 3.141926536 and so on. In all these examples, we see that there is no pattern in the decimal form. Dear students, we can also define the rational and irrational numbers in terms of terminating, non-terminating, recurring and non-recurring decimals. So in case of rational numbers, we say that all the terminating and recurring decimals are called rational numbers, and all the non-terminating and non-recurring decimals are irrational numbers. Now we are in the position to define the set of real numbers. If we take the union of rational and irrational numbers, we get the set of real numbers. So in the set of real numbers, we have all the integers such that positive integers, negative integers, including 0, all the numbers in square roots, pi, e, and all the numbers in fractions. That's all.
Dear students, Assalamu alaikum. I am your mathematics teacher. Today we will start exercise 2a. In question number 1, we are given different numbers and we have to classify these numbers into rational or irrational. We make two columns, one for rational numbers and the other for irrational numbers. So let's see. In part A, we have minus 3, which is an integer, and so integer is a rational number. B, 0, 0 is integer, so it is a rational number. 3 by 4 is of the form P by Q, and it is the rational number. 1.5 means 3 by 2, which is of the form P by Q, which is also a rational number. 1.4 is a terminating decimal, so it is rational. 5 by 3 of the form P by Q, rational. Square root of 16 means 4, and 4 is an integer, so rational. 0.8 dot 7 dot means 0.8787 and so on. So it is the recurring decimal, and we know that all the recurring decimals are rational numbers. And last, 50 is an integer, so rational numbers. Let's go to the other side. The square root of 14 plus square root of 41, it is an irrational number, because we know that all the square roots are the numbers in the square roots are irrational number. So 3 plus square root 5 is also an irrational number. Pi is equal to 3.14115 and so on. So we know that all the non-terminating and non-recurring decimals are also irrational numbers. Square root 5 and square root 2 are definitely irrational numbers. Thank you.